Question 4. There are 4 human blood groups. They are OA, B, and AB. Each person has one of these blood groups. The table below shows the distribution of blood groups in a large country. 2 people are selected at random from this country. Find the probability that at least one of them has blood group O. Okay, so there's a couple of ways to do this. Looking already at question part 2, find the probability that they have different blood groups. I'm actually going to recommend a tree diagram. A tree diagram is going to show me all the possible outcomes that we could get from this, and we'll maybe talk about the quicker way to do or deal with this afterwards. Okay, so here's the tree diagram with all the different blood types and what might happen as I choose the first person and as I choose the second person, running out of space here. Okay, so let's go ahead and find the probabilities. Well, we already know these probabilities, so these can be added to those branches. And the other branches would have those probabilities as well. Nothing changes in between the first and the second person. But I can find all of the possible outcomes. Probability that they both have blood type O, probability of OA, probability of OB, etc. Okay, these are all the possible outcomes, and here we have them with all the calculations, and here's all the final probabilities. It looks like a lot. Here's all the possible things that could have happened, and I can answer any question about the probabilities by making reference to these. So find the probability that at least one of them is in blood group O. Well, I'm looking at this, all of these, so add these 4 together, just this, this, and just this. So all of those values added together is going to give me the probability that at least one of them is in blood group O. And adding all of those together, we do get an answer of 0.7399. Okay, so next we were asked to find the probability that they have different blood groups. Okay, so from here I can see that these are the ones that I'm looking for, or even better, the ones that I've not highlighted are the ones that I don't want. So how about I subtract away the ones that I've not highlighted. So we get 1 minus 0.3954, which leaves us with 0.6046. That's the answer that we're looking for. Okay, so this was actually quite a complex way, especially with the tree diagram being so large. How could we have got there a little bit quicker? Well, we still need to have a good idea of what all the possible outcomes may have been to begin with, and we'll use those to generate an alternate and a quicker way to get these probabilities. Okay, so right from the beginning, I want to find a probability at least one of them has blood group O. So I know that's all of the probabilities unless both of them didn't have blood group O. So let's just have a think about that. I can regroup all of these to be basically blood group O, and all of these as one group together, not blood group O. Okay, so the probability of blood group O equals 0.49, and the probability of not blood group O equals 0.51. So the probability that at least one of them is going to be in blood group O is going to be 1 minus the probability that both of them are not in blood group O. All right, so that's 1 minus the probability that one minus the probability that both of them are not in blood group O. So that ends up being 1 minus 0.51 squared. That would be the probability that both of them are in blood group O, and those are the only ones I don't want to include. So that gets us straight to 0.7399, very fast. Similarly, on this second question, because we have a good understanding of all the possible outcomes that we might be working with, I've realized that the probability that they both have different blood groups. So that means the ones that I don't want are OO, AA, BB, and ABAB. So I can do a similar thing and remove all of the duplicates where both of them are from the same blood group. So starting with 1, I'm going to subtract all of the people who are, I'm going to subtract the combination where both of them are blood group O, subtract the combination where both of them are blood group A, subtract the combination where both of them are blood group B, and subtract the combination where both of them are blood group AB. Okay, and from there we can quickly get our answer, 0.6046. So you can appreciate how much quicker it was when we thought about it this way, but this depended on me having all those outcomes for the tree diagram in my head. If you haven't thought about those, you are going to make mistakes in going through it this way, and the tree diagram, as long as it is your only option.